Okay, so we kind of ended on the last video with this slide. I just wanted to come back to it relatively quickly because what happens is oftentimes we may or may not be given the population proportion or the sample proportion before you start the study. So think about it this way. So when you're planning a study, our goal is potentially to come up with a margin of error before we even start or before we even pick the sample, because we're choosing the sample size in order to get a certain margin of error. All right, so there are two different ways to get this proportion before the study even starts, because if you think about it, like, you're not going to have a p-hat if you're choosing the margin of error in the sample size before you even do the study. So sometimes what will happen is you might have a guess of what p-hat is for the particular study that you're looking at, and you might use that as your p-hat in figuring out what your sample size should be to come up with a certain margin of error. Or if you aren't sure, there's no pilot study or anything, you're going to use p-hat as 0.5 as your guess, all right? The margin of error is the largest when p-hat is equal to 0.5. So that's going to give you the largest margin of error, which is going to tell you, okay, it's actually going to make your sample size larger than it actually needs to be. Because if you think about it, 0.5 times 0.5, when you do your n times p, that is actually going to give you, it'll give you the largest margin of error. So that's what you're going to use, 0.5, whenever you're not given a proportion. So it's often called the conservative approach when you use p-hat is equal to 0.5 if the proportion is not given in the problem, if we don't have a pilot study. Because like I said, if you're looking for a margin of error and trying to find the sample size before you even start the study, then you won't have that p-hat, so you'll just use p-hat as 0.5. All right, so this is the same thing that we did in the sort of the last section. So oftentimes when you do a study, you want a particular margin of error and you want to choose your sample size based on that margin of error. So this is your margin of error formula. Remember, this is just your standard error. It's the standard deviation of the statistic. So to find out the margin of error, we use our p-hat, 1 minus p-hat, our sample size, and our critical z-score. Okay, so if we're trying to find a sample size that will yield a confidence interval for a population proportion P with a maximum margin of error, you're basically going to solve this for n. And if you want to go through and solve this for n one time and just know that every single time, go for it. I always just use this formula, that I don't have to memorize a second formula. Okay, so why don't you go ahead and try this one. This one is asking for how large a sample size is needed, and then go ahead and check your answer on the next slide. Okay, so this one is a little bit tricky before we go on. So this one's asking how large a sample size is needed. We want the margin of error to be a maximum of 3%. We know we want a 95% confidence level. Now, you might think in this, wait a second, okay, for this question, I'm not given a proportion. However, we are sort of in this section right here. So because the president wants to estimate the proportion of customers who are satisfied, which either satisfied or very satisfied, the two highest levels on the 5-point scale. So in that case, our p-hat here is going to be 2 out of 5, because those are the two that we're actually looking at, okay? So in this case, you are given your p-hat value. All right, so we're trying to determine the sample size needed to estimate our population proportion within 0.03 for our margin of error with a 95% confidence. Our critical value for 95% confidence is 1.96. Hopefully you have that memorized by now. We have no idea about our true proportion P of satisfied customers, so we use p-hat as 0.5 as our guess, okay? So there's actually sort of two ways to do this question. I guess I've done it both ways, but I would accept both answers here. So if you use that as your proportion from the previous one, that's okay, but since it's not actually stated, you could also use the conservative method as 0.5 as your guess. Because the company president wants a margin of error of no more than 3%, we need to solve the equation, the margin of error has to be less than or equal to 3%. So right now we're just plugging everything into our formula. So we're plugging in 1.96. We know that this is 0.5. 0.5 times 0.5, we leave the n there, less than or equal to the 3% margin of error. I sort of did everything one step. I divided this by 0.03. You can make this 2 square roots, one on the top and one on the bottom, so I moved that square root of n to the other side. Basically squared everything. So if I squared this side, I'd have to square this side. So you can square this and then square this, take rid of the square root, square that, solve it, get your answer. Okay, now what you could also do here though, you could literally just like do 0.5 times 0.5, take the square root, multiply by this, then square both sides. That's totally fine. So it says n has to be greater than or equal to 1067. So that actually gives you, remember that you can't, if you do 1066, what's going to happen is this is going to be too large, okay, and it's not going to give you a margin of error less than or equal to 3. It'll be bigger, so you have to round up to 1068. Okay, so just be really careful with that. And if you're ever not sure, honestly, just plug that number back in and see if it gives you a margin of error less than or equal to 3 or whatever we were looking at in that case. Okay, so suppose we want to estimate the true proportion of students at your school who have a tattoo with a 95% confidence and a margin of error no more than 10%. Once again, because we don't have any previous knowledge about the proportion of students with a tattoo, we're going to use our proportion to be 0.5 to estimate the sample size needed. So once again, we're just plugging our information in, 95% confidence, like I said, hopefully you have that memorized by now. Plugging your information in, and you should get 96.05. Notice how its n is greater than or equal to 96.05, so you need to survey at least 97 students to get a margin of error that's less than or equal to 10%. All right, so in this section, we stated and checked the random 10% in large counts condition. We found the critical values, and you constructed and interpreted the confidence intervals. The next section, what we'll be looking at is we'll just be taking a look at constructing and interpreting confidence intervals for sample means.